All right, hello students, I'm back. I believe we left off on example 3. Assume the training heart rates of all 20-year-old athletes are normally distributed with a mean of 135 beats per minute and a standard deviation of 18 beats per minute. Random samples of size 4. Stop, time out. 4, we're under 30. Whenever your group is under 30, you got to be really careful. Can you do the problem or not? So in order to know if you can do the problem, you have to go back to the central limit theorem. If your group is under 30, you can only do the problem if the word problem says it's normally distributed, if it is a normal distribution. So let's go back. It says, assume the training heart rates of all 20-year-old athletes are normally distributed. It specifies that it is, therefore we can do the problem. If it would have said here, skewed left, skewed right, or uniform, we would have written, can't be done. So let's continue on. So I want to find the mean of the group is equal to the mean of the population. It says the mean right here is 135. And it says that the standard deviation of the group is equal to the standard deviation divided by the square root of n. The standard deviation of the population is 18. And we're dividing that by the square root of n. And in this case, n is 4. So pick up my calculator. Oh my gosh, me shaking the phone today. I'm so sorry. So if I do 18 divided by the square root of 4, I get the number 9. And now I'm ready to go 1, 2, 3 bars up, 1, 2, 3 bars down. 135 goes in the middle, and now I'm going up by 9. If you can't do that in your head, that's okay. That's why we have technology. 135 plus 9 is 144, plus 9 is 153, and plus 9 is 162. Going to the left, 135 minus 9 is 126, minus 9 is 117, and minus 9 is 108. And there is your problem. Example 4. The diameters of fully grown white oak trees are normally distributed, that might be important, with a mean of 3.5 and a standard deviation of 0.2. Random samples of size 16. Stop, time out. Whenever you're under 30, you need to double check whether or not you can do the problem. A size of 16 is obviously under 30. If it's under 30, we can only do the problem if the word problem says it's a normal distribution, and we underlined that it is normally distributed. Therefore, we can do the problem. The mean of the group equals the mean of the population, which is 3.5. The standard deviation of the group equals the standard deviation divided by the square root of n, which is 0.2 divided by the square root of, we're taking groups of 16. And pick up my calculator. 0.2 divided by the square root of 16 is 0.05. So 3.5 in the middle. 1, 2, 3 lines up. 1, 2, 3 lines down. And 3.5 plus 0.05 is 3.55 plus 0.05 is 3.6 plus 0.05 is 3.65. Now I'll go to 3.5 minus 0.05 is 3.45. Minus 0.05 should be 3.4. And minus 0.05, you should guess it is 3.35. And we are done with that page. Next page. Get a little harder. The figure below shows the mean distances traveled by drivers each day. You randomly select 50 drivers. 50 drivers is over 30. We're good to go. Ages 16 to 19. So we're looking in this category right here, the ages 16 to 19 category. What is the probability that the mean distance traveled each day is between 19.4 and 22.5 miles? All right, so I'm not finding the probability of one, I'm finding the probability of a group of 50 drivers. So the first thing I need to do is find the mean of the group is equal to the mean of the population, which is equal to what is the average Number of miles driven by 16 to 19-year-olds, that is 20.7. And it says right there in the chart, the average miles driven by each day by each age group. The standard deviation of the group equals the standard deviation of the population divided by the square root of n. In the word problem, I tell you to assume that sigma is 6.5, and we're dividing that by the square root of n, which is 50. Now here I'm not going to divide it out because I don't need to draw my picture. I'll show you what we're going to do on our calculator. But what I do want to find is I want to find the probability that this falls in this little area right here between 19.4 and 22.5. So I want to find the probability of a betweener problem. Go all the way back to 5.1 when I taught you betweener problems. In betweener problems, you put the 19.4 here, you put the 22.5 here. Now, in 5.1, we put z in the middle because it was standard normal. In 5.2, we put x in the middle because it was regular normal, but now it's not standard, it's not regular, we're now doing groups. What symbol do we use for groups? We use x bar for groups, and we still use less thans. All right, now, again, we're going back to 5.1, and I want to find this probability. In 5.1, we use the button normal CDF. So I'm going to pick up my calculator. Hold on, turn it on. Second dister, number 2. My lower bound for my shading here, look at your shading. Your lower bound is 19.4. Oh, let's try that again. I typed that in wrong. 19.4. The upper bound is 22.5. Now, the mean, we're finding the mean of the group. The mean of the group is equal to the mean of the population, which is 20.7. The standard deviation of the group is this standard deviation right here, and you don't need to find this. Your calculator will do this for you. All you have to do is type in 6.5 divided by the square root of 50 and hit enter. It will find that for you. You don't need to divide that out and put some nasty, ugly decimal there. Hit enter, and your answer to the problem, we always round these to 4 decimal places. 1, 2, 3, 4. Let me move this over closer. 1, 2, 3, 4 should be 0.8962 is your answer to the problem. 8962. And there's your answer to example 5. All right, example 6. You randomly select 100 drivers. So now you have a group of 100 people, ages 16 to 19 from example 5, our same group. What is the probability that the mean distance traveled each day is between 19.4 and 22.5 miles? But now we're changing the standard, the mean. Assume that is 20.7 and assume this is still 6.5, but now we're not taking a group of 50 drivers, we're now taking a group of 100 drivers. So here we go. The mean of this group is equal to the mean of the population, which is still 20.7. The standard deviation of the group equals the standard deviation divided by the square root of n. The standard deviation I give you is 6.5. But now instead of 50 drivers, we now have a group of 100 drivers. I still want to know the probability of it landing between 19.4 and 22.5. So again, it's a betweener problem. 19.4, 22.5. It's not Z, it's not X, it's X bar. We always use less thans. Again, I'm going to go to my normal CDF button on my calculator. So second dister, there we go. Let me do that again just in case you didn't see it. Second dister, number 2. My lower bound is still 19.4. My upper bound is still 22.5. My mean is still 20.7. But now my standard deviation is 6.5 divided by the square root of 100, not 50. Hit enter, and our answer is 0.9744. And there's your answer to that problem. This is probably a good point for me to stop this video because I need to be able to load it up onto YouTube. So give me just a second and I'll be right back.